Hi, today we are starting off with the very first design pattern, that is factory method design pattern. So before I start off with the traditional method of explaining you what it is and then how it is, let us start off with a piece of code. So let's say I have a software which deals with the delivery part. So if it is a small consignment, I use a bike. If it is a comparatively little bit big consignment, I use a car. If it is cross city or something, I would use a truck. As all of them has the method drive, so I would ask them to implement interface. Why? To have dynamic method dispatch. Okay. What is dynamic method dispatch? In a nutshell, what we can do, we can create a vehicle type data type, and we can just name it as obj, and we can assign it anything like new car is also valid. In the same manner, new truck is also valid, because all of them are just implementing this interface, so we can have dynamic method dispatch. If you don't know it, just google it, you would have a better picture of this. Fair enough, this code looks very good. So what we did was, inside the main or the client class, we wrote a code something like this. Okay, so if the delivery type is a car, we would have a new car associate assigned to the obj, and if the delivery type is bike, we would do the same thing, and then we would write obj.drive. This looks very good enough, but there are still some problems to it with respect to solid principle and do not repeat yourself. What are the problems to it? The very first problem, which is open closed principle or tight coupling. Let me explain you this. And by the time I do 2 or 3 videos of design pattern and you are with the flow of explanation, you would get a hang of this. Okay, let's start off. So see, if you observe at this point, the client class is very tightly coupled with truck and bike. What do I mean by this? Let's say tomorrow a new method of bike comes in. Like, let's say after the bike is done, we should check if it is parked properly or not, because bikes are comparatively unsafer in roads. Let's say I have some post creation logic. So I need to change in the client class. And now everyone who is using this big module, every client who is using this big module would also need to do the same thing. So I need to edit this class itself. And open closed principle tells us what? A class should be open for extension but closed for modification. But here we are modifying it, and it is very tightly coupled. Like even if some process of car changes, like closing the window of a car after it is parked, that also we need to write it in the client class. If let's say tomorrow releasing the truck driver or ensuring if the truck driver has eaten something or not, because it is a long trip, that also needs to be written in the client class. So very tightly coupled code it is. Then the very next issue we have is, of course, the scalability. What is the issue of scalability? Let's say my software has grown big. Now I am software as a service. So what do I mean by software as a service? So what happens is, in very large industry, when your business grows a lot, you start serving other businesses too. Like for example, what can be done is, like if you observe, Google Maps is also there in Ubers, Google Maps is also there in Rapido, and Google Maps is also there in Google Maps. That is software as a service. It is providing its service to other. In the same manner, if we have a microservice architecture, then we can take up this module and we can give it to a different team that you can use this module. Okay, now see, the object creation logic is in the client class. So now everyone who is using this module needs to start changing if anything in this module change. This is very problematic if you observe. I would explain you in real world analogy, because people who have not worked in the industry, that is very difficult. So see, it's like I gave a piece of code and I would say this code would calculate addition and subtraction. Now let's say every time I enhance this code or change anything in the code, everyone who is using this code, I need to notify them. This is very problematic. I should be modifying the things in such a manner that they don't need to change. We don't want to bother the clients who are using it. The more botheration you would do, more friction would be there, and it is not applicable. So, in the same manner, this has a scalability issue because every time we change something in the creation logic, we need to let know the clients. And this is not like, let's say there are lakhs of clients. That is a problem here. And the very next thing, do not repeat yourself. What is this? Every client who is using it needs to write this logic everywhere. So this is violating the do not repeat yourself. Like we are repeating the same piece of code again and again, again and again. These are the problems associated with this code. Now, see, let's use a very generic problem solving idea to solve it, and then we would see what can be done. So now, if we take a closer look at the problems that are existing, see, open closed principle or tight coupling is there because of what? Because this client class is handling everything. Scalability has a issue of what? Because everyone needs to copy this client. Do not repeat yourself, everyone needs to copy this one. We need to notify the client, that is because of scalability. Do not repeat yourself, everyone is copying this code. So if you observe, the code here is the problem. So what we can do is just use the problem solving ability. You don't really need to think of a design pattern or something. Just think of very simple idea. If I encapsulate this logic in something like vehicle factory, if I encapsulate this logic in vehicle factory and I ship this code with this big module, now I would be the one. If I change up this vehicle factory, every client would get changed. So scalability is now solved. Now if you observe, it is not tightly coupled. Why? Because this is only responsible for the creation logic of everyone else. It is not responsible for do anything else. Rather than client was responsible to do its own job also. But here I can just change up the logic here, and every client who is using this would have the same method itself. Okay, just we added a layer in between. Okay, so see, writing everything in the client was an issue here. So we encapsulated that logic in a class and we shipped it together, and that solved the problem. And this way of encapsulating the creation logic in a different class and shipping it with the code is a design pattern. So it provides an interface for creating objects in a superclass, but allows superclass to alter the type of objects that would be created. That is there. Now if you observe, this pattern solves the problem of object creation. That is why this is a creational design pattern. Fair enough. Now, what are the downsides to it? It increases a function overhead. Why? Because earlier the client was directly instantiating and then using it. But now there is a middle person in between. Now the client class would interact with the factory and the factory would interact with the designated object. So we have a function overhead. So if you have a very simple logic where only one or two type of classes are to be decided and not a lot of classes would be there in the future, so you should consider using that in the client only. Okay, because encapsulating that in a class would just increase the function overhead. Okay, so that was it for today. This doesn't have really so much of pros and cons to talk about. So whenever we just encapsulating the object creation logic is factory method design pattern. Okay, hope I tried to seem it as simple as it is without using the traditional DB connection method or telling you what is factory. So if you liked and if you think that this should be taken forward, just subscribe to this video. Thank you and have a nice day. Goodbye everyone.